Good morning, everyone, and welcome to this Salesforce platform webinar. Today, our topic is data models, relationships, and SOQL. Um, just by way of introduction, my name is Rob Woodward. I'm a platform solution engineer, and I'm based here in the UK. I've been working with Salesforce now for approximately 2.5 years. As a platform solution engineer, I get focused on all things to do with Salesforce platform. That includes things like Heroku. But our focus today is very much around Force.com and the way data and queries and relationships are constructed within that part of our platform. Now, if you've sat in any other Salesforce presentations, this is probably no surprise to you, our standard public safe harbor statement. If you want the full text, please just go along to the website. You can download it from there. But basically it says if you are making any buying decisions, please make it based on currently available technology and not on any forward-looking statements. Fortunately, today I'm not expecting to talk anything about futures. This is all about what's here and now and available within the Salesforce platform. So our agenda, broken it really down into two parts. The first part is the data model and relationships piece, talking about what the data model is, and specifically comparing it with typical relational database management systems that you might have used in the past, and pointing out some of the differences that can trip people up when they're first exposed to Force.com. Also talk about the different types of relationships within the data model environment, and this idea that joins or connections between objects are predefined, and that's an important topic to consider. In the second part, we'll dive more into the query language, SOQL, and how that differs from standard SQL that you may have used in the past, and how to construct relationship queries. We'll be doing some demos as we go through. If anybody wants to ask questions, we are in listen-only mode in terms of audio, but you can ask questions through the panel in the GoToWebinar software. So please, if you do have questions or as you think of them, just jot them down in there. I'll pause a couple of times and review those and see how I can best answer those during the course of the webinar. So one or two assumptions. We're kind of assuming that you have actually touched Force.com already. I won't be giving you a detailed explanation of how to navigate around the UI or, in fact, details about how to create objects themselves. Fairly self-explanatory, and we have other webinars that go into those topics in a little bit more detail. I am also assuming a basic knowledge of relational database concepts, so the idea of tables, of primary and foreign keys, and the idea of joining these tables together to form new relationships. So that's our starting point for today. So let's dive into the first part on data model and relationships. So in Force.com platform, we talk a lot about S objects. There are more general purpose objects in Force.com, just code-based objects, classes in our programming language. But there is a thing called the S object, which is both, if you like, a table-like structure stored in our database. It's also a programmable structure, and it's exposed directly into the language. We're not really covering the Apex side of working with objects here today. We're just focusing really on the storage part and the way that you might query it using the SOQL language. So S objects are, at first glance, very much like tables in a relational database. You can think of them as a grid or a matrix or a spreadsheet, if you like, with a set of columns across the top with predefined headings, predefined types of data in the column. And then you can have as many rows as makes sense. All of the data is added row by row, and we talk about each individual row in the table-like structure as a record. So Salesforce terminology is to talk about S objects. Each each row becomes a record, and the columns themselves are the fields of the S object. Every S object has some standard fields. We'll talk a bit more about that, but they are intrinsically extensible. We provide a number of standard S objects as part of the system, and depending on what applications that you're working with in Salesforce, perhaps you're using our Sales Cloud application, then you'll get additional objects which you can also extend with your own columns, your own fields, perhaps your own validation rules and the like. So it works as a database. It's queryable. You can express queries, and you can also update that data, of course. And you can create, and we'll look into this in much more detail, relationships between the objects, which allows you to define things like master detail relationships. Classic ones would be things like accounts and contacts. You have a master account and then multiple detail contacts hanging off that account. There are a number of automatic features built into the platform. So for instance, as soon as you've defined an S object, you will automatically get the user interface built for you. So you can enter data, you can browse through the data, you can construct views that show different subsets of that data automatically. Again, we're not really focusing on the user interface side of this today. But I draw your attention to some other webinars we've got coming up in the future to cover off those topics in a bit more detail. There's a full security model built around the S objects. CRUD, if you're not familiar with it, stands for create, read, update, delete. So you can simply define which kind of users and their user profiles are allowed to create records for a particular object, whether they can read them, whether they can update them, or whether they can delete them. That's probably the highest level of security. You can get down into the field level and say certain people can see certain fields only. So maybe there's a particularly sensitive field against a contact record. It might be somebody's personal information, such as their age, which is relevant except for perhaps somebody who has privileges as an HR person within an organization. So you can control field level security. You can also control it down at the record level. So if you've worked with other systems where you have things like access control lists that define who gets to see certain records, in other certain rows, so you can really lock down the security on the object model so that people only see the correct rows and columns within your S objects according to the way you've defined it. The other thing you get automatically when you create an S object is an API to it. So as soon as you've defined it, it becomes immediately accessible through our REST and SOAP APIs. Again, of course, security is enforced, whether you're coming in through the user interface or through the API, it's the same security. And also, of course, you'd actually want to give a user API access before they'd even be able to come in through that particular route and get access to it. So there are a number of standard objects that we supply, depending on which piece of Salesforce. If you've just got the basic force.com, you'll have things like account and contact. If you're using the CRM product, the Sales Cloud, you'll have additional things like leads and opportunities and cases, perhaps. So these are the standard objects we supply. There's also a whole raft of system-level objects. If you start browsing around using one of our tools, you'll see many other objects that are storing important system data that actually makes the whole platform hang together. Within any standard object, there's a set of standard fields. Every object gets an ID. This is the primary key. If you're thinking in relational database terms, this is the primary key, and every object gets a standard ID field. It is, if you look at the value, you'll probably see a 15 or possibly 18 character string of alphanumerics. It's not meant to be human readable in any sense. It has no real meaning. The first few characters of it indicate the type of the object, and the remainder indicates which particular record that you're referencing within the object. Those IDs, if you've got the 15 character one, they're case sensitive. If you've got the 18 character one, they're designed to be case insensitive, and you can convert between the two. Every object also gets a standard name field, which is an 80 character text string, so that you can store a basic name or title or description of what this object is. There are also other system-generated values such as created by dates, last modified by dates, who did it, who is the owner of the record. So we have the concept of record ownership throughout Salesforce. So every individual record is tagged with an owner. By default, if you create a record yourself through the API or through the user interface, you become the owner of it. There is also the idea of a recycle bin, so that when you delete records, they're simply tagged as deleted, and in the database, the isDeleted flag is set to true, and that gives you the opportunity to undelete at a later stage. So I mentioned that the data model is extensible, so you can create your own custom objects, such as workshop and room, and create your own custom fields, as you'll see over on the right-hand side. You can come up with any name you like for these, but whatever you create, it will always have an __C tagged on the end of it automatically. And this ensures that there's no clash between anything that you create and any of the standard fields or standard objects that Salesforce uses. So it's a little hard to see in the slide here, but that's actually a double underscore. And it's really important that you use that anytime that you're referencing this in some kind of code, such as the SOQL that we'll be playing with later on. You remember to use the __C name. So in a standard relational database system such as Oracle or Microsoft SQL Server, you can create very similar kind of idea of tables, and then you can create joins between them simply by issuing a SQL query and saying select from, and then listing out the different tables that you want to reference and some kind of criteria to say which of the common rows do you actually want to retrieve. So the joining process in a relational database management system is done by the SQL itself, by the query, or perhaps sometimes in the form of a view, which is kind of a predefined query that returns a different way of looking at the data. That idea doesn't really exist in the same format, though, here in Force.com. So instead, the linkages between different objects are actually predefined at design time. So over in the graphic here, you'll see a picture of the schema builder that we'll be playing around with a little bit later on. And you'll see the line joining the two objects together with the crow's foot at one end, indicating a one-to-many relationship. So a room can contain multiple workshops. But this is actually defined at design time and stored as metadata in the system. It's a little bit similar to integrity constraints. So in a pure relational system, you can just join whatever table to whatever other table you like based on matching information between them. But some systems allow you to start to define lots of integrity constraints to say you can only do things in certain ways. There are certain rules about what you do. So it's a little bit more like that system. There are, in fact, two types of relationships within the Force.com platform. We call them lookup relationships and master detail relationships. In many respects, there are a lot of similarities, but there are some important differences. So if we look at, for instance, nullability, so if you create a lookup relationship between two objects, it's optional whether there's anything to look up to. You can leave it as null. You can say it doesn't look up to anything at all. And that is different to master detail, as we'll see in a moment. The delete behavior, if you delete the main object that's being looked up to, you can either say, well, clear anything that was referencing it, or actually deny that, actually prevent it from going ahead. Let me just build out the rest of the slide so we can contrast these a little better. In master detail relationships, you never get a null relationship. You can't have a detail dangling around, a detail record with no master to refer to. So that is never an option, whereas in lookup it is. The delete behavior for master detail is always to cascade. So if you delete the master, it will remove all of the detail objects. Record sharing is a little out of scope for our discussion today. It's a way of controlling the access control behavior as to who sees which records. In master detail, if you can see the parent, generally speaking, you can see all of the children that are related to it. But in lookups, they can be completely independent, so you may be able to see the parent record and not any of the children, or vice versa. There's also quite a strict restriction on the number of master detail relationships. In practice, I've never really found a need in any of the work that I've done for more than two, and we might see that a little bit later on, whereas lookups you can have plenty of. So let's have a look at this in action. As you've seen from the previous slide, I'm focusing on the idea of rooms and workshops in, let's say it's a community center, so they've got a number of function rooms that they can make available, and they have a number of different types of workshops, whether they're exercise classes or craft workshops or whatever. So clearly a room can support many different workshops, and a workshop would happen in a specific room. Let me escape out of my slides here. So here we are in the force.com home page. If you set that up as your default home page, if you're not a regular user, you're more of a developer, this is a typical landing page that you'd come into, where you've got all of the configuration menu options down the left and things that you've been recently working on available here. I'm going to use the schema builder, which is available under the build option here. Let me click on that. And because it remembers what I was looking at last time, it's pulled up from all the available objects that are in my current Salesforce org. It's showing just the two that I've got selected, and we can add and remove other ones in as necessary. Drag these around, and you can see the relationship being mapped out between them, and they're drawn out in two different colors. So lookups appear in blue, master details appear in red, and anything that's a required field, as you'll see here, has got the little red bar against it. So this is my basic data model that I've already created. The interesting part here is the linkage between the two. So let's have a look at this relationship, and if I double click on room C, which is the reference in my workshop object to rooms over here, we can see the details about that relationship. It gets the name. When you enter it, you don't put the __C in, remember, it adds that on automatically. You can add some documentation information, some help information. It has a pick list. It's grayed out at the moment because once you've set it, it's remembered. And then you've got the related names available here. So you can see that it's going to be referred to as workshops. It's very common when you're defining objects, it asks you what the name of the object is and what the plural name is, and we'll perhaps make use of that a little bit later on. Come back to that. So if you think of this more in, again, in relational database terms, this is the foreign key, if you like. What's stored in here is an identifier, an ID value. So every room over on this side, although it's not showing the ID field as it's implicit in everything. Everything has an ID, and what we're storing is the ID of a specific room over in Workshop to create that reference. We'll look a little bit more about IDs and relationship queries in the next section as to exactly how that works. But of course, you'll be familiar if I open up another tab here. You can create tabs in the user interface that list out the data in my object, so I can get a view of all the rooms. Here they are. We can change which columns are being displayed. Might be nice to see, for instance, the room capacity. Save that. I seem to have taken the room name off, never mind. And then we can see the workshops that are available. So we've got a great one here, Yogalicious, and it will have a reference back to the room. And in the UI, you'll get a pick list. So you'll see the little ability here to go in and edit this. So if I double click it, I'll get the ability to go and look up and find other rooms. And of course, I haven't got any rooms starting with D. But if we do a search, all rooms starting with E, pick out Elm, select that one, save the change. So you're actually manually setting up that relationship. Although you're using the pick list, what's physically being stored back in the database is the ID of Elm. And the UI is doing all the work for you to say, don't worry about that, I will display for you the actual name of it, because we don't really want end users having to worry about the IDs. You can see an example of an ID up at the top here. You'll very often see them in the URL. This is referencing the first three characters. The first three characters are the type of object. So A0Q means it's a workshop. You don't really need to know that, but that's how the system's working. And the remainder identify that it happens to be the Yogalicious one. So standard objects have standard, common, 3 letters at the start across everybody's org. So if you're working with accounts and contacts, it'll always be the same. But if you're working with custom objects, it's assigned when you first create it. If I can drill through from here and go and look at Elm, and you'll see that Elm has multiple workshops. So this is looking at the other end of the relationship and seeing the many. So from this direction, go back to my schema builder. If I'm looking at room, I can walk this way and see many workshops. If I'm at the workshop end and follow it back, I'm only going to see the single room that it's in. So here we get the related list, as it's called in Salesforce jargon, which is the list of workshops that have been assigned to this particular room. So if I click through onto any of these workshops, you'll see it's referencing Elm. So depending on which end of the relationship you're looking at, it's displayed differently in the UI. At one end, it's just a field with a pick list, and at the other end of the relationship, it displays as a related list down here. Let me just pause and see if there are any questions. I'm not seeing anything at the moment. Remember, if you do want to ask something, please use the facility built into the GoToWebinar software. Ask a question, and I'll be checking again later on after another demo. So let me return to my slides. So we've looked at the basic data model and basic relationships within the system. When it really starts to get interesting is when we start to work with those relationships and the Salesforce object query language, or SOQL, as I like to call it. So let's look at SOQL. It's a SQL-like syntax, and that's a good thing because it's immediately familiar. It's also it can also trip you up because it's not quite the same, and there are some important differences which I'll draw out as we go through. It's used to query the objects, as we've talked about, the objects that we've been creating. It's being used to generate and fetch the data behind those user interface screens that we were looking at. The user interface is doing it all automatically for you, but if you get into customizing the user interface, building your own pages with Visualforce or Apex, then you'll be having to supply your own SOQL to go and fetch the data that you want displayed. So SOQL can be used in the Apex programming language. You can use it, as we will this morning, in the various developer tools like the developer console, Eclipse, Workbench, or any of the other third-party tools that are starting to appear. And you'd also use it from external applications through the API. So you can make a call through REST and say, go get me all the workshops that are, let's say, booked in a particular room. So as I mentioned, it's got a similar syntax to SQL, and as a result, at first it looks quite familiar, but there are some really important differences, and it's really important that you spend a little bit of time learning what those differences are. But it's fair to say that good data design practices are common across all platforms. It's just important that the assumptions that you're making when you're making those design decisions are the correct ones for SOQL, which are different to SQL. And a colleague of mine came up with the analogy that it's a little bit like an optical illusion. You start looking at one corner of the triangle and it looks all very familiar and straightforward, but then as you go a little further in, it all gets a little bit weird and confusing. So there's an interesting analogy to be drawn between starting with SOQL and transferring to, starting with SQL and transferring to SOQL. So over on the right-hand side here, this is the familiar stuff. Go get me some columns of information, select ID, name, and capacity from an object, and then only get me those records that match the criteria in the where clause. So I only want those where the room capacity is greater than 10. That could be pulled straight out of SQL, and other than perhaps the __C being a little odd, but again, still valid SQL. So everything looks similar so far. Data is indexed in force.com. You don't have quite as much flexibility on what is indexed as you might if you were running your own database. You have to remember Salesforce is a very large multi-tenant platform. So although these look like tables, we're actually doing quite a lot of work under the covers to hide the underlying database from you and provide a multi-tenant infrastructure that everyone can use, and everyone gets to use fairly, if you like. So you can't run really long, horrible, complex queries that are going to crunch away for hours and hours and deprive everybody else of CPU time. So there are many parts within the force.com platform that apply what we call limits or governors to ensure everybody gets a fair usage of the system and no one is adversely impacted by anybody else who's using the system. It is a transactional database. It does have the idea of commits and rollbacks, so you can decide at a certain point within a procedure that things aren't going the way you want and you'd like to roll back to the state before you started. So those ideas are also implemented. And it also provides an extensive trigger capability so that when data changes are applied to the database, you can intercept them and add your own custom logic, again using the Apex language to control what happens. You can add additional validation rules, you can cause updates to other parts of the system or even to external systems if that's required. And that's an extensive part of the Force.com platform. So what's different? Well, immediately if you start playing around with it, you will see that there is no select star. I think something everybody who plays around with SQL at some point just does select star from a table name and just gets all the data from it to have a quick look at what's going on. So select star is not supported. You do have to explicitly identify which columns you want to select. This is one reason I think for this is that you can have very wide objects in Salesforce. We allow up to 500 columns at a minimum, so it's very common to get some very wide objects, and selecting everything isn't necessarily that useful. Also, there are no views. You can't define a view as you might in SQL that joins two other objects together and gives you a compound view of them. That concept really does not exist at all. So anytime you want to do some kind of relationship query that joins multiple tables together, you have to create it each time. There's no way to sort of pre-build that and give it a new name. So that concept doesn't exist. Another thing that catches people out is that the SOQL language itself is in fact read-only. You cannot do an update using SOQL syntax. You might say, well, what's the point of having a database I can't update? Well, of course, the updating is all done through the Apex language. So SOQL is the query piece. It allows you to express what to fetch, what records to fetch from which objects, using which criteria and using which relationships. But it doesn't let you do the update. Having fetched all that data back, it will then sit in objects in the Apex language, and it's using Apex syntax that any inserts, updates, and deletes are performed, as well as commits and rollbacks. I mentioned it's indexed. Obviously, the primary key, that ID field, is always indexed because we use that heavily. All the relationships are based around IDs and not on user-entered data. So every record that's linked to another one is based on that explicit linkage that's set up using the ID fields. Those are indexed, of course. The name fields are indexed. You can also have what we call an external ID. So it's very common if you're pulling in data from other systems that already has some kind of primary key information. You want to preserve that. So you can create what we call an external ID field. Might be an invoice number or something that's come from your account system that's considered the primary key in that environment. So you can create external IDs and they will get indexed. But it's not as flexible in the sense of you can't create arbitrary indexes on columns to assist in performance management. The object relational mapping is also automatic. So in a lot of languages where you have a programming language and a query language, you have to do quite a lot of work to help tell the programming language how to use the query language, or if you've used the query language and you get some results back, where to put them and how to map them into objects in your programming language. because our programming language and our query languages are very tightly integrated, all of that is done automatically for you. So if you're a programmer and you're getting started out with our Apex language, it's very quick, very easy to issue SOQL queries in the language, get the results back, put them into Apex objects automatically, and then start working with them in your own custom logic. So you don't need any mapping files, XML files, or any of that stuff that you might have seen in other environments. Schema changes protected, what does that mean? Well, it means that if you've referenced in your code a particular field, then the system won't let you remove that field from the database. So it protects you from breaking your logic by editing the data model. In a more traditional relational database environment, you can make changes how you like, and then when some program comes along and accesses it and tries to read a particular column that you've just deleted, it will usually just return an error. Whereas because we're one tightly integrated environment, we won't let you remove something from the database in terms of a column or even a whole object if it's being referred to somewhere in your application logic. So first of all, you'd have to update the application logic or disable it so it's no longer active, and then you'd be able to make those schema changes. So there are some things that are quite substantially different. S objects are not actually tables. Yes, we do place under the covers to actually physically store things, but when you create an object using force.com, you are not creating a table in the underlying database. Remember, this is a scalable multi-tenant environment. So in fact, everything, every object, every row goes into one big table. Discussing this in more detail is a bit beyond the scope of today's webinar, but you can read some great white papers on our developer website that talk about this in much more detail. And for those of you with a more architectural mind, I would strongly recommend that you do that. It's a really interesting read, and it will really help with your underlying understanding of how force.com manages data. We talked about this idea of predefined joins. That joins are predefined in the, as you saw in the schema builder, you set up that link, and that is the only way that you can join objects together. You can't just arbitrarily take two tables and some SQL and sort of combine them in some arbitrary way. So effectively, the joins are predefined, the referential integrity is part of that, as we've discussed with things like cascading deletes and the like. It does involve, though, a specific query syntax in the way SOQL works. We looked at a bit of SOQL that just accessed a single object and some columns, and it looked pretty straightforward. But as soon as you get into accessing multiple objects in a single SOQL query, the syntax starts to diverge quite a lot from standard SQL. The other thing that often trips people up when they first start working with force.com is, again, this idea of multi-tenancy and the fact that your usage is being metered. And the reason to do that, as I said, primarily is to ensure that everybody gets fair usage and no one query can adversely impact any other parts of the system. So there are a whole set of governor limits and batch limits to ensure that everybody gets equal use of the system, each individual user across all the users in the multi-tenant environment. And that can create some design considerations that you may need to bear in mind as you're designing your application. We've already seen the __C suffix. This is what we call the API name of any object. So when you define an object, you'll call it room, and that will become the label of it, the name of it in the UI. You can use things like Translation Workbench to have different labels for different languages. But you also get automatically room underscore underscore C, the API name, and that doesn't change even if you change the label. There is another suffix called underscore underscore R, and it's really important to get your head around this in terms of working with relationship queries. So here we have the one-to-many relationship that we had earlier. I'm displaying it on the screen here. To implement that in our workshop, we have room underscore underscore C defined as a field. The type of that field could be a lookup or a master detail, doesn't really matter in this example. And physically stored in that field is the ID of the room that we're referring to from the workshop. Automatically, though, you get another kind of pseudo field called room underscore underscore R. You don't have to do any more work to define it. It exists, and you can query against it. And the type of that is the type of the object that you're referencing. So if you think of these two in terms of data types, underscore underscore C, if you're working with a master detail or a lookup relationship field, will always be that ID, that unique key that tells us which record to go and point to. But the underscore underscore R is essentially the thing at the other end of that reference. It's the room itself. And on the flip side, you get something added into room, and it's kind of the inverse relationship. It also gets an underscore underscore R suffix, and the name of it is usually the plural of your object. So in this case, it's workshops with an S underscore underscore R. So this is the reverse of the relationship. So remember, when we're working from right to left, going from workshop to room, we're going from many to one. So it's really easy. We can just go and find a specific room. But if we're going from left to right, we're going one to many. So there could be many workshops in a given room. And so the data type of this is actually a list. Now, don't worry if you don't understand the syntax I'm showing there with the list and the angle brackets. If you're working with the Apex language, this will be more familiar to you. We're saying this is a list of things, and the type of thing in that list is a workshop. So hopefully, I come back to this slide in my own head many times when I'm working with the system, and we're trying to remember what it is I'm trying to do here. Do I want the ID? Do I want the record that the ID points to? Or am I getting a relationship where there are multiple? In that case, I'm getting a list of objects. So here are some relationship queries, and let me walk you through them. If you start on the left and look at the black text, we've got a really simple query. Select some columns from an object, workshop C, where the status is set to open. And over on the right-hand side in white, you can see the results. I'm actually using the JSON notation to draw the results. That's a bit arbitrary. Obviously, JSON isn't natively being used here by Salesforce, although you can work with JSON if you want to, using the programming language. Particularly useful for working with REST interfaces, for instance. But it's a good way of just mapping out what you get. So you get a list of things because we're selecting multiple workshops. So I've got the first workshop, Yoga for Beginners. The second one is another Yoga for Beginners, but with, I was going to say, but with a different ID, but I've just spotted a typo in these slides. They should have different IDs. So points to anyone who was looking at that going, you've got the same ID in the two of them, which wouldn't really happen. So so we've got the two results, and we're getting the columns that we requested, ID, name, and room. But if we now extend the query on the left to add in things from the parent. So this is looking from my workshop and saying, okay, what room am I in? I can only be in one room, so it's nice and easy. So we use the relationship notification, the __r, and say, go get me from the related room the ID and the capacity. And you'll see over on the right, we get a result with the 2 extra values. But notice how it's sort of nested within, and that's you can think of the dot notation as creating this structure. So you get a thing called room R, and inside that are the 2, the ID and the capacity fields that we requested. So what happens if we flip that around and go parent to child in our query? Well, if you remember back to my previous diagram, when you're going parent to child, you'll get multiple results from the relationship, potentially anyway. So to do this, we use the idea of a nested select. So again, if you look on the left, the text in black generates the output in white on the right. And then we add in the green bits. And you'll see I get a nested result with multiple values in it. And that represents the list that we were talking about before. So depending on which way you're querying relationships, whether you're going parent to child or child to parent, the syntax is rather different. In both cases, you use the __r notation, but in one, you simply use it to reference the field you want, because we've only got a single record, so it's really easy. But in the alternative, we may have multiple records, so we use this idea of a nested select to go and get all of that related information. Just as a pointer, you can, when you're doing relationship queries, the where clause can reference things both from the main object and also the referenced object. So if you want to say, only get me information about workshops that are in a room of capacity greater than 8, you can add that into your where clause. So the where clause can also traverse multiple objects, which is quite nice. There is also the idea of aggregate queries. So just as you would in SQL, you can do counting things, summing things, finding the mins, max, and averages of things. The additional bit of syntax here is to add the group by, just as you would in SQL. And also to provide alias names, so that, as you'll see the green, it just gives us a way of having a nice simple name for the result without any, you couldn't really call it count brackets ID, because that wouldn't be a valid name. It can't have brackets in it. So you have to provide an alias for each of the aggregate values that you're returning. So let's quickly see that in action. Let me drop out of the slides for a moment here and back to my main screen here. Let's jump into the developer console. So if you've not worked with this before, this gives you access to your Apex code, your Visualforce pages, your objects, and also provides in the tabs down at the bottom here a nice little query editor. So we can start by saying, let's select ID from workshop. Let's not forget to put the __c in. Actually, all of this is case insensitive. I'm going to do it pretty much in lowercase, just for speed of typing. You can generally, I would capitalize the reserved words and put initial capitals on things, but just for speed here, I won't. So there we go, a list of IDs from workshop. Well, that's not very useful at this stage. Let's add in the name so we can see exactly what we're getting back. So here are all my different classes starting to appear, and you'll notice I get a tab with each different set of results appearing in. And we can start to say, let's just say where. Let's say we only want those that are not currently open. So we want the status is not equal to, that's an exclamation mark, is not equal to open. So it would be useful, actually, before I do that, let's add status in here. So if I just leave that out for now, and let's say, show me the statuses as well. So you've got all sorts, including open. And if I add in the where clause and execute it again, all of the ones that were open. Take out that spurious equals that I seem to have got in there. All the open ones have now disappeared from my list. So far I said very similar to SQL, no significant differences. But if I now wanted to say, well, okay, which room are these workshops in? This is where it starts to deviate a little bit. And I use the __r syntax to get the room, the corresponding room. It does actually compile the query as you go. So you will see errors here if you've got syntax, you see it's checked it and said, hang on, there's something wrong. But if I keep on typing, it'll catch up with me as I go along. So let's get the room. Well, no, let's just get the room __c for a moment and see what that gets us. You'll see it gets us the ID, which again, for most purposes, isn't really usable. Some of them are null. This was a lookup relationship, so we are allowed to have workshops that currently have no assigned room. If it was master detail, you wouldn't be able to do that. You wouldn't have any nulls present. But I don't want the ID. I want the actual object at the end of that ID. So I use the R notation, and then I can fetch the name of that particular room. Let's try that out now. So now it's coming back with the room name. Where the ID was null, it's telling me that it has no value because it doesn't know what room to go and look up. And let's go get the capacity of that room as well. How many seats have we got available physically in the room? So add room R and capacity C. Okay, let's make a bit more room here. Well, let's see my capacities. Okay. Hold please, what's going on here? Let's take a look here. Item status room. There we go. Double underscore. And now we've got the capacities coming in. So it even trips me up from time to time as to what to type in. So we're getting those capacities. It would be great just to do a bit of summation on that. And we can just do that really quickly. If we want to say, let's total those capacities up. So if I'm going to start summarizing on a particular room, so I want the total capacities that I'm not using for Beach and for Elm. So let's drop out the columns that we can't summarize on. Let me have the sum of this now. And let's add in that all-important group by. There we go. So now it's done the totting up for me and summarized it and grouped it by each of the rooms. Okay, let's jump back into the slide deck. So we've been looking at data models and relationships. There's a lot that's very similar if you've come into this from a standard relational database background, but there are a lot of important differences that we've covered somewhat briefly, and obviously if you look at our documentation you can find a lot more detail about that. One of the key concepts is this idea of the predefined join. You have to tell Force.com what is the foreign key, what is the linking object, the linking field between objects, and what type of relationship it is. Is it a master detail or is it a lookup? So there is the concept of relations, but it's not a relational database in the pure sense of the term. You do have to watch out for limits. We really haven't covered that in any detail here, just alluded to it. But if you try and retrieve millions and millions of rows, you'll get stopped at some point and said, no, you can only have a certain amount at any one time. But good design principles are generally valid. They don't go away, but you just need to make sure that the assumptions that you're making are right. Are the things you're assuming, are they indexed, for instance, in the way you think they are? Do the relationships work in the way you think they do? As long as you're applying those principles with the correct assumptions, you should be in good stead. Let me just pause to see if there are any questions, because I'm conscious we've just got a couple of minutes left. There's one question I've got here. What about many-to-many relationships? We've talked about one-to-many, and obviously many-to-one, the opposite end of it. But what about many-to-many? Well, yes, absolutely, you can do that. If I flip very quickly back to my browser here, we can just check that out. If I go into the schema builder, I've got the idea of attendees and contacts. Here, a bit more of my data model that I wasn't showing you. By creating a one-to-many and a many-to-one with a table or an object in between, you effectively create many-to-many between workshops and contacts. So that's the way to do it. It's two relationships with what we call a junction object in between. In this case, it has an extra field saying whether that attendee is confirmed or not. So yeah, good question. Back in my slides now. Some follow-up reading, obviously sharing these slides and the presentation later on, some good links here, some good article about that, how to get to SOQL if you've come from a SQL background, obviously the core documentation, a bit more about limits and that all-important info about our underlying architecture. So we are